Let us discuss some numerical examples using multivariate random variables. Let x1, x2, x3, x4 be 4-dimensional random vector where each xk are independent Poisson random variables with parameter 2. So it is given that, let x1, x2, x3, so 4 random variable only, x3 and x4 be independent Poisson random variables with each xi having Poisson distribution with parameter lambda I. So here it is given that it is 2, lambda is equal to 2. So x1, x2, x4 be a x3, x4 be a 4-dimensional random vector where xk are independent Poisson random variable with parameter 2. So here actually I just similar because they are independent random variables. So I wrote x1, x2, x3, x4 are independent random variable with xi are with Poisson random variable with parameter 2. So what will be the probability mass function? Because here you can see that each having same distribution. So they are not only independent, they are identically distributed random variables also. So in this case we say x1, x2, x3, x4 are IIT, independent identically distributed random variables. So what will be then the probability mass function? The probability mass function of xi is given by, because it is Poisson random variable, pxi of, so I am writing, so instead of xi we can write commonly some because it is a variable only, it is nothing but, so it is probability that random variable xi is taking some value x. So it can be represented as e to the power of minus lambda, it is 2 to the power of x by x factorial, whenever x can be 0, 1 to anything and 0 otherwise. So because here only identically distributed random variables, so all have same for I is equal to 1, 2, 3 and 4. For all the random variables, the probability mass functions are same. It is e to the power of minus 2 to the power of x by x factorial, x is equal to 0, 1, 2. Now the question is that find probability of this x1 is equal to 1, x2 is equal to, because it is a multivariate random variable, we can talk about jointly it is taking this value 1, 3, 2, 1. So what is the probability? Find now probability that x1 is equal to 1, x2 is equal to 3, x3 is equal to 2 and x4 is equal to 1. So let us see that x1 is equal to 1, x2 equal to 3, x3 is equal to 2 and x4 is equal to 1. So now how we can find this? Because we can find this value when if you know the joint probability mass function, but we don't know probability mass function, but we have this information that x1, x2, x3, x4 are independent Poisson random variable. So from the marginal we can find their joint. So because they are independent, so this is nothing but probability that x1 is equal to 1, probability that x2 is equal to 3, probability x3 is equal to 2 and probability x4 is equal to 1. So we can write product of their marginal probability mass function. So this is, so we can see that, so this is x1 is equal to 1, if you put I is equal to 1, x1 is equal to 1 is e to the power of minus 2, 2 to the power 1 by 1 factorial, x2 is equal to 3, I is equal to 2, so all have same probability mass function. So it is e to the power of minus 2, 2 to the power 3 by 3 factorial, e to the power of minus 2, 2 to the power 2 by 2 factorial, x4 is equal to 1, e to the power of minus 2, 2 to the power 1 by 1 factorial. So 1 factorial. So then we can write e to the power of minus 4 into 2, 8 and then 2 to the power of 1, 3 plus 1, 2, 5 plus 3 plus 4 plus 2, 6 plus 1. So 2 to the power of 7 by all these value 1 factorial 1, 3 factorial 6, 2 factorial 2, so 6 into 2 12. So we can write okay, so 3 into 2 square. So then we can write e to the power of minus 8 2 to the power of 5 by 2 to the power of 5 by 3. So this is nothing but this is just simplified 32 by 3 e to the power of minus 8. So this is the probability. If you can use a calculator to find the some fraction, if we can write in a decimal format, so then we can have so exact value. So otherwise this is also okay, it is in this form also we can keep. So this is the, this should be the probability. Now next, I hope you have understood this clearly how to find this probability, because it is just using the independence concept. Using independent concept we can find this probability. Now probability, find the probability that exactly one of the x's equal 0. So next we have to find, this question is that find the probability that exactly one of the xk's equals 0. So one of the xk equals 0. So that means there are 4 x1, x2, x3, x4. Exactly one will be xk equal to 0. So that means, so suppose there are 4 values. So one possibility that, so x1, x2, x3, x4. So one possibility that exactly one is 0. So maybe, so let us see this question again. So it is asking that find the probability that exactly one of the xk is equal to 0. So one of the xk means it may be x1 is 0. So then it is not equal to 0. This is also not equal to 0. This is not equal to 0. So similarly other possibilities are, so x1, x2, x3, x4. So x2 is exactly 0, but because it is asked that exactly 1 is 0. So if other cannot be 0. So like this 4 possibilities will be there, because 4 random variables are there, exactly one of the ith value will be 0. So this probability can be written as probability that x1 is equal to 0, comma x2 not equal to 0, then x3 not equal to 0, x4 not equal to 0. And then because they are mutually exclusive events, we can write plus x1 not equal to 0, x2 is equal to 0, x3 not equal to 0, and x4 not equal to 0, plus probability that x1 is equal to 0, x2 is equal to 0, x3 not equal to 0, and x4 is equal to 0, plus probability that x1 is equal to 0, x2 is equal to 0, x3 is equal to 0, and x4 not equal to 0. So these are the 4 possibilities we are adding, because they are mutually exclusive. By assume 3, it can be added. So now this how is the probability, because they are independent random variables. This joint probability we can write their probability of their marginals. This is x1 is equal to 0 into probability x2 is not equal to 0 into probability x3 not equal to 0, probability x4 not equal to 0, x4 not equal to 0, plus similarly we will write that x1 not equal to 0 into probability x2 is equal to 0, probability x3 not equal to 0 into probability x4 not equal to 0, plus probability x1 is equal to 0 into multiply with probability x2 is equal to 0, probability x3 not equal to 0, probability x4 is equal to 0. So in that case I just made some mistake. See that in that case 1 it is 0, no, all are non-zero. In that case x2 is 0, all are non-zero. In that case x1 not equal to 0, x2 not equal to 0, then x3 is 0 and x4 not equal to 0, and plus probability x1 not equal to 0 and probability x2 not equal to 0, probability x3 not equal to 0, and probability x4 is equal to 0. So these are the 4 probabilities. Now we have to know how we can find what is x1 is equal to 0. So x1 is equal to, for any value xi is equal to 0 for any I by the random variable. Xi is equal to 0 is nothing but, if you put x is equal to 0 here, it is e to the power of, so let us write somewhere. So let us here, okay, this is the space. So how we can find xy is equal to 0? If you put x is equal to 0 here, so e to the power of minus 2, 2 to the power of 0 by 0 factorial, e to the power of minus 2. Now if we can want to find for I is equal to 1 to 4, and how xi not equal to 0 we will find. So we know that because it is a probability mass function, summation of all possible value 0 to infinity p of xi is equal to small xi, or let take x, the value only, the value x is equal to small x, this is variable only. So this is equal to 1. So that's why this is sum of xi is equal to 0 and xi not equal to 0, this should be equal to total is equal to 1. So that's why we can write like this. We know that probability that xi is equal to 0 plus probability that xi, the other value 0, this should be total value, it will be equal to 1. So because xi not equal to 0 means it contains the other 1, 2, 3, 4 like that. So which implies probability that xi not equal to 0, because it is a complement of this event. So this should be equal to certain event. So probability xi not equal to 0, it will be nothing but 1 minus probability of xi is equal to 0, which is 1 minus e to the power of minus 2. So that information we will write, and it is true for I is equal to 1, 2, 3, 4. So that's why this is we will find xi is equal to 0 is e to the power of minus 2, and then it is 1 minus e to the power of minus 2, then 1 minus e to the power of minus 2, 1 minus e to the power of minus 2. Similarly, for this case also x1 not equal to 0, because it is true for, because they are identically distributed random variable, it will be true for all I. So x1 not equal to 0 is 1 minus e to the power of minus 2, then it is e to the power of minus 2, 1 minus e to the power of minus 2, and 1 minus e to the power of minus 2. So like this we same plus the same quantity, again plus same quantity. So then basically you can see that this is 3 times this, and so e to the power of minus 2, then 1 minus e to the power of minus 2 whole cube. Here also same, e to the power of minus 2 and 1 minus e to the power of minus 2 whole cube, plus same 2 times it is repeated, same values it will come, you can check, and then this will be nothing but 4 e to the power of minus 2, 1 minus e to the power of minus 2 whole cube. So then we found the value. So there are some other method also to find this probability, because it is asking find the probability that exactly 1 of x is 0. So then you can redefine this random variable in such a way that you can use the binomial concept. For example, let us discuss, suppose yi is the, let yi be the random variable defined as yi is equal to 1 if xi is equal to 0, which is equal to 0 if xi not equal to 0. So then it is a Bernoulli random variable. So then we know that probability of xi is equal to 0, we found it to the power of minus 2, and probability of xi not equal to 0, it is 1 minus to the power of minus 2. So then it is a Bernoulli random variable defined by probability mass function is nothing but probability of y of 1 is e to the power of minus 2, that probability. So basically we can write, because this is true, which implies probability of yi is equal to 1, this is same as xi is equal to 0 e to the power of minus 2, and probability of yi is equal to 0 same as xi is equal to 1, which is 1 minus e to the power of minus 2. So xi not equal to 0, that we know that. Now it is asked that exactly, so then if you consider sum of these random variables, suppose w is equal to y1 plus y2 plus y3 plus y4. So it is a binomial distribution with parameter 4, p is nothing but yi, because they are all identically distributed random variable and independent. So this probability is e to the power of minus 2. This is the probability, binomial distribution. Then it is asked that exactly one of them is 1. So find the probability that exactly 1 of xk is 0, sorry, xk is 0. So 1 of xk is 0 is equivalent to, if you take the sum see that 1 of xk 0 means one of the y1, y2 or y3 or y4 will be exactly equal to 1, because xi is 0 means yi is equal to 1. So, exactly one of them 1 means the sum will be is equal to 1, because 1 remaining 0. So, it is asked that, which implies, so probability that, hence the probability that exactly, so what is it is given, the probability is asked that, probability that exactly one of the x's equal 0, probability that exactly one of the xk's equals 0 equal to 0 is nothing but probability that w is equal to 1 basically, because whenever one of the xk is 0 is yi will be 1, one of the y will be 1, remaining 0. So, by binomial we know that what w, so binomial distribution, what is the probability mass function? So, this is 4c1, then p to the power of minus p to the power of 1 and 1 minus p, 1 minus the probability, and then 4 minus 1. So, this generally we write that w is equal to some small w, this is the random variable small w, this is 4c small w, then p to the power of minus w, 1 minus to the power of minus e to the power of minus t w, for w is 0, 1, 2, 4 actually, maximum 4 it can take. So, this is the general w is equal to 0, 1, 2, 3 and 4, because 4 total we are adding, and this is 0 otherwise. This is the binomial probability mass function. From here we can put, so 0 otherwise. So, from here if you can put this w is equal to small w is equal to 1, then you just replace 1, 4c1 e to the power minus 2 whole to the power 1, 1 minus e to the power minus. So, this is 4c1 is how much? This is 4, and then e to the power of minus 2, e to the power of minus 2 and 1 minus e to the power of minus 2 whole cube. So, this is the answer. So, this is different approach to find this, solve this problem. So, that we got here also. So, like explicitly we did it, what is the probability, but this approach is more general approach, because here you can see that this number of things we have to add and then you have to find this value, but if you ask something else, so then suppose if you ask that some of the 2 xi will be 1 remaining xi will be exactly 0. So, in that case we have to use this binomial concept. So, we have to take this transformation. So, this is the concept of transformation of random variables also we will learn in the next weeks. Some of the lectures you will find that transformation of random variable, how this transformation of random variable is useful for finding the probabilities. These are some of the concept. So, this is one numerical example we completed here. So, we will discuss another numerical example now. So, let x, y, z be a trivariate random variable where x, y and z are independent uniform random variables over 0, 1. Compute probability of z greater than equal to x, y. So, here it is in the previous example it was discrete random variable, here it is continuous random variable. Let us do this problem. Let x, y and z be trivariate random variable, actually it is given that independent also, trivariate random variable where x, y and z are independent uniform random variables over 0, 1, where x, y and z are independent uniform independent random variable over 0 1. So uniform random variable over 0 1. So then because they are independent random variable and also they are same random variable, like they are all uniform random variable over 0 1. So they are independent and also identically distributed random variables. So then what is their marginal probability density function? So the probability density function of, so x and y all are having same probability density function. So let us find marginal probability density function of x is, so this is f of x, this is because it is uniform random variable, this is 1 if you can remember that x between 0 and 1, it is 0 otherwise. So we discussed this continuous uniform random variable over a interval AB. So it is 1 by b minus a, this is 0 is the a and b is the upper limit b minus a is 1 here. So that's why it is 1 here, 1 by b minus a, 0 otherwise. And also the marginal probability mass density function of y is same, just this variable changed, 1 if y belongs to 0 1, this is 0 otherwise. And also the marginal probability density function of z is f z z, this is equal to 1 if z belongs to 0 1 and this is 0 otherwise. Now these are the marginal probability density functions. Now what will be the joint? Because it is independent random variables, so we can find the joint probability density functions. So the joint probability density function of xyz is given by fx xyz xyz. So because it is independent random variables, we can, so we know that it can be multiplied f of y and z. So then f of x, f of y and f of z, it is given here. So this is nothing but 1 into 1 into 1, 1 if x, y, z all are belong to 0 1, otherwise it is 0. So this is the joint probability density function. So from here we can find this answer. So here it is asked that be a type of random variable x, y, z are independent uniform random 0 1, compute probability of z greater than equal to x, y. So as this joint probability density function now known, so then how we can find z greater than equal to x, y? So probability that z greater than equal to x, y. So this value we have to find, probability, this is the question, z greater than equal to x, y. So how we can find that? So this is we have to, so whenever this is like a region in a 3-dimensional space, so this region we have to do integration. So we have to find this, so all this x, y, z in this 3-dimensional place, so belongs to suppose R3, satisfying this z greater than equal to x, y, and then we on this region we will do this probability joint probability density function, we have to integrate dx, dy, dz. So now already, because we can change this, assuming that it exists, actually it will be it exists because total sum is 1. So minus infinity to plus infinity, if we do the integration, it is because it is a joint probability density function. So then we can change the order of this integration also. So because the this region is defined by 0 to 1, 0 to 1, but for z it is greater than equal to x, y. So we can write first integration, this is for z it is x, y to 1, and for other cases it is 0 to 1, this is 0 to 1, and then this is in this region only whenever x and y between 0 to 1 and z has to be greater than equal to xy also, not only that it will be more than, because x and y already greater than 0, so it is taking care. So it will be, so then this is 1, so then this is dz first, and then dx, then dy. So then, or dz, dy, dx. So now first if you integrate with respect to dz, then z, you take the limit. So this is 0 to 1, 0 to 1, 1 minus of xy, 1 minus of xy, and then it is dy and dx. So then first we do the integration of, so let us first, this is 0 to 1 dx, and dy, then this will be y, 1 minus 0, this is 1 minus, so then x is a constant, so x into y square by 2, y square by 2, limit 0 to 1. So this will be the integration with respect to y. So then 1 already we have taken, so then y square by 2, it is 1 by 2, 1 minus x by 2. So this is 0 to 1, 1 minus x by 2 dx. So then this is x again, x 0 to 1 is 1, and then this is 1 by 2, and then x square by 2, so 1 by 4, and then this is x square, this is 0 to 1, so this is 1, so 1 minus 1 by 4, so this is nothing but 3 by 4. So this probability z greater than x equal to xy, it is equal to 3 by 4. So hopefully you have understood it. So how to compute this kind of probability using joint probability density function. So this is just one example. So you can go through some of the references to find more examples, then you can practice those examples to understand it more clearly. If you have any doubt, then you can clarify it also by practicing those problems, and next we will discuss another numerical examples.